Hi, I'm Miss Sarah, and this is At Home Makerspace, where I show you how to make fun projects with things you can find at home. This summer, our library is offering a really fun summer reading program, and the theme is Tales and Tales. If you're interested in learning more about our summer reading program, be sure to check out the link in the description. Now, as you might have guessed by the name Tales and Tales, here on Makerspace, we'll be doing all sorts of fun animal-themed Makerspace projects. In this video, we'll be exploring magnetism through some hands-on projects like making our own compass and making our own electromagnet to explore how animals use magnetism. You might be wondering, what is a magnet? Well, it is an object that can pull certain types of metals towards itself. This pulling force is known as magnetism, and the objects that are pulled are magnetic. Our first experiment will be testing things around the house to see which ones are magnetic and which ones are not magnetic. You'll need a magnet and some objects to test. I'm using a plastic container, sunglasses, cereal, a nail, paper clips, a wrapped candy, a pencil, and a spoon. To test if an object is magnetic, all you need to do is place a magnet on the object. If the magnet sticks, it's magnetic, and if not, it's not magnetic. As you can see, the first three things I've tried have not been magnetic. Now let's try something that is magnetic, like the spoon. Do you see how the magnet sticks to the spoon? The spoon we know is magnetic. All right, so the pencil, even the metal part doesn't appear to be magnetic, but the nail is, the paper clips are, and let's see about that foil wrapped candy. It's not magnetic. Once you've tested all your objects, you might want to separate the objects that are magnetic from the objects that are not magnetic. In our case, we had three magnetic objects: the nail, the paper clips, and the spoon. It turns out objects are magnetic if they contain iron, steel, nickel, or cobalt. When you try this experiment at home, I encourage you to make some guesses about which objects you think will be magnetic and which objects you think will not be magnetic. You can then use your magnet to test if your guesses were right. And I used a button magnet from my refrigerator for these experiments because this is the kind of magnet I have at home. You should feel free to use whatever kind of magnet you have at home to do your experiments. So you could use a long, thin bar magnet or a horseshoe-shaped magnet. Those will all work for these experiments. But if you are using a really strong magnet, I encourage you to have an adult help because strong magnets can be a bit more dangerous. All right, so we've learned that magnets can pull metals towards themselves, but what happens if we have two magnets? Here I have two magnets, and each magnet has a north pole and a south pole. If I place them so the opposite sides are together, you can see that they attract. But if I flip one of my magnets over, I can actually feel the magnets repelling one another. So, when it comes to magnets, a north pole will be attracted to a south pole, but a north pole will be repelled by another north pole, and a south pole will be repelled by another south pole, which brings us to our next experiment. You may have heard that the planet Earth is like a giant magnet. It even has a north pole and a south pole. The Earth's magnetic field can actually interact with other magnets, which we'll explore by making our own compass. You'll need a bowl filled with water, a metal needle, A magnet, I'm using this small button magnet from my refrigerator, some paper, scissors, and possibly a pencil. The first thing I'm going to do is cut a circle out of my paper. This circle should be slightly bigger than the length of your needle. And if you want, you could use your pencil to trace out your circle, but I'm just going to go ahead and cut. This paper will help our needle to float on the surface of the water. Another option would be a piece of cork if you happen to have any cork around the house. Okay, so the next thing we're going to do is magnetize our needle. So I'm picking a needle out of my pack. I chose a medium-sized needle for hand sewing. And now I'm going to magnetize it. So I'm going to draw one end of my needle over the magnet. I'm moving it always from left to right. And since my button magnet is not particularly strong, I'm actually going to draw my needle about 30 times. If you have a stronger magnet at home, you probably won't need to do it quite so many times. Okay, and when I'm done with that, I'm going to turn my magnet upside down and turn my needle around. So this time I'm going to be drawing the eye of the needle over the other side of the magnet. Once again, I'm going to be moving it from left to right, and I'm going to do this about 30 times. If you happen to be using a bar magnet or a horseshoe-shaped magnet with the North and South Pole labeled, make sure to draw one end of your needle over the North Pole and the other over the South Pole. With our button magnet, one side is north and the other side is south. Okay, so now I'm going to be placing my needle into the piece of paper by poking it through, then turning it so it can poke through the other side, like that. And finally, I'm going to be placing the paper atop the water. It will take several seconds for your needle to align. If you wait for it to stop moving, your needle will be lined up so one end is pointing north and the other end is pointing south. To figure out which is which, you can grab a compass, and we can now see that the eye of the needle, this end, is pointing north, and this end, the pointy end, is pointing south. So we can use our compass to help us figure out directions, like which way is north and which way is south. But we're not the only ones who use magnetism for directions. Many animals can actually use magnetism to help them figure out where they are and where they need to go. Basically, these animals have an additional sense. So let's think about the senses we know. For example, we have a sense of hearing that can help us detect sound, and a sense of smell that can help us detect scents. Well, some animals have an additional sense called magnetoreception that allows them to detect magnetic fields. Animals with magnetoreception include homing pigeons, honeybees, sea turtles, and salmon. But how do these animals sense magnetism? Well, one explanation is that some animals have tiny magnetic particles inside of their bodies. These magnetic particles align with the Earth's magnetic field, and so this directional information can be conveyed to the animal's brains. For another explanation, let's move on to our final experiment. Another way to create a magnet is by passing electricity through certain kinds of metals. We'll be exploring this concept by making our own electromagnet. You'll need some thin insulated copper wire. The copper is this orangey color. Some wire cutters or scissors if you don't happen to have wire cutters. An iron nail, bolt, or screw. A battery. Some electrical tape. And something metal that you can pick up with a magnet. I'm going to be using some paper clips, and as you can see, the paper clips can be picked up by a magnet. If you're unsure if something is iron or steel, the iron will appear darker and less shiny. To begin, I'm going to test our nail, and as you can see, it is not magnetic, it's not picking up the paper clips. If we want to turn it into a magnet, we'll need to build our own electromagnet. And to get started, you'll need some insulated copper wire. Go ahead and wrap the copper wire around the nail. You want to pick a wire that's pretty flexible so that it's easy to wrap. Continue wrapping until you've reached the end. When you're done wrapping, go ahead and grab your wire cutters or your scissors and cut the wire, but be sure to leave a tail. Next, we'll want to remove the insulation from this tail so that the wire is exposed. Wire cutters would be better for this, but if you don't have wire cutters, you can use your scissors to very, very carefully cut around the insulation. I do recommend getting a grown-up to help you with this part. Once you've cut all the way around the insulation, you should be able to carefully pull it from the wire. And if your nail slipped out like mine did, make sure to slip it back into your coiled wire. Next, we're going to be attaching the ends of our wire to our battery using some electrical tape. Go ahead and cut a nice long piece of electrical tape. Then line up one of the ends of the wire against one of the ends of your battery. Secure that in place. Then you can attach the other wire and secure that as well. When you attach the wire to the battery, it could become quite hot, so the tape will help hold it in place and keep us from touching that hot wire directly. If the magnet doesn't work the first time, double check that the wire is touching the ends of the battery. And when you're sure it's secure, try it out. And as you can see, there we go. We've now magnetized our iron and turned it into an electromagnet. So as we saw, passing electricity through certain metals generates a magnetic field, but the opposite is also true. Creating a magnetic field generates electricity. So let's get back to animals. Scientists know that some animals can actually sense electricity. Once again, this is similar to how our sense of hearing, for example, can detect sounds. This sensitivity is known as electroreception, and it's found primarily in aquatic animals or animals that live in the water, because water is a really good conductor of electricity. So animals with electroreception include sharks and rays. These animals use electroreception to avoid predators and find prey when they can't use their eyes to see, such as in underwater caves or murky water or at night. Scientists believe that being able to sense electricity means these animals can also sense magnetic fields, which they may use to help them navigate. We hope you enjoyed learning more about how animals use magnetism by trying some hands-on experiments. If you try any of these experiments at home, we'd love to see them, so please leave us a comment or take a picture and share them with us at the library. You can do so through our Facebook at www.facebook.com/FHCPL, through our Instagram. Our handle is @FHCPL, or you can send us an email. Our email address is makerspace@findlaylibrary.org. Don't forget to sign up for our summer reading program. Once again, the link will be in the description, and I hope to see you again soon. Bye!